Hello, this is video 48, and as you can see, once again, I did some work in advance. This is a dependency graph for our program 4 assignment. Dependency, D-E-P-E-N-D-E-N-C-Y, and clearly it's not a tree because it's got cycles in it, so it's a dependency graph. What good is a dependency graph? Well, if we start at the top up here, you'll notice that all these in green boxes, if you can see the colors clearly, everything in green boxes is either a .h file, a header file, or a .cpp file. In other words, all these green boxes up here, roughly this line and above, these are all source code that either you typed in or I typed in or somebody typed in, and they haven't been changed to machine language. When they are changed to machine language, they become object code. Now, this is in the context and also the point of view of running on a Linux system. So even though the source code, maybe that runs on your Mac using Sublime and all that other stuff, and maybe you use code blocks on a PC, on the Linux system in the lab, which is a universal system that every computer scientist should know their way around, we are very aware of these different life stages of our code. So it starts off as source code. You type it in some editor, maybe an editor that's not even on the same machine. At any rate, you end up with all these source code files that you need for your project. Now then, those have to be translated to machine language by the compiler. That's what G++ does. That's part of what it does. It translates, for example, the program4.cpp file into an object code file called prog4.o. And if you played around with ls when you did your Linux lab assignment, then you did see .o files in your directory after you did the compilation with the G++ command. So program4.cpp source code translates to machine code prog4.o, an object file, which is not complete. It's not ready to run yet. It has to be linked together, perhaps, and usually, with other object code, the libraries and so forth. Even our own object code has to be linked together before it's runnable as an executable. Get a little bit ahead of the game. All these pink boxes right here, hot pink, this rbt.o, that's the machine language version of rbt.cpp. So the compiler took rbt.cpp and translated that into rbt.o for us. And by the way, this is assuming there are no errors. Otherwise, we would not even be here. We would not have this glorious dependency graph that we could talk about. The mp3.o, that came from mp3.cpp. So we see a pattern developing here. Each one of these .cpp files, that source code, translates into an object code version via the compiler. The compiler translates each CPP file into a separate .o file. That's the object code. Then the linker, you know what, I'll even label that. All this stuff right here, this dotted line, all the green boxes above the dotted line, the compiler, C-O-M-P-I-L-E-R, whose job it is to translate source code into machine code. The compiler gets us from the green boxes down to the level of the pink boxes. Now, the pink boxes, all this zeros and one object code that the compiler generated, those have to be linked together, another dotted line here, to go from the hot pink boxes down to this one and only one blue box at the bottom. That's our executable code. You can give it a name, and we'll see how to do that when we do some G++ commands for where we're headed. But if you don't specify a name, like I want my output file name to be prog4, then you get the a.out that you know and love from the experimenting you've done with Linux already. So this would have been our a.out file, but I said, you know what, this is program 4's executable, let's call it prog4, and it's the linker that takes the pink boxes and ties them all together like assembling a jigsaw puzzle into the program 4 executable file. Linker. Okay, so there's our dependency graph that shows how all these different life stages of all of these different source code files, how they fit together. What do the arrows mean then? Well, I'm going to start at the bottom. Since I started at the top last time, I'll start at the bottom this time. Program 4 depends on what program 4 object code looks like, and our red black tree object code, what that looks like, and the mp3 data type that I gave you, what that looks like. So the dependency is I can't be a program 4 executable if I don't have these three files and have them linked together. What does the prog4.o depend on? Well, what object code this becomes depends on what's in our .cpp file. What's in this one depends on what's in the RBT file, and we see how to play this game. The mp3.o depends on what's in the mp3.cpp file. Perhaps most mysterious are, what are all these brown arrows up the top here? Well, here's the key. Suppose randomly I choose a header file. Boom, I choose this. Oh no, red, black tree. I put green and yellow instead of red and black for my colors. Silly me. So I have to go in and edit my RBT header file. If I change anything about the RBT header file, that in effect, think about it real hard, in effect changes the RBT.cpp. That's what these source code dependencies say. Since I changed the file that's included in RBT.cpp, in effect, I indirectly edited the contents of RBT.cpp. Okay? So, what the RBT.cpp file actually is, when the curtain parts and we see how things are connected together, what it actually is its own contents and the contents of RBT.h. Okay? The significance of that is I made a change in RBT.h, then all of a sudden RBT.cpp is out of date and all the way down back to the bottom. If this is the only place where I make a change, I edit this and then save it to disk, then that means that this file, not the others, but this file is going to have to be recompiled because the object code is not valid anymore. It's not up to date. So this will have to be recompiled so I get a new version of RBT.o. And I just now, I spied an arrow. I misspoke a little bit, didn't I? prog4.cpp also depends on RBT.h. So here's what the arrows tell me. If I make a change to RBT.h, since both of these source code files depend on that, and by depend I mean they in effect change if I change RBT.h, then if these two source code files change, it means both of these pink boxes are out of date. They both need to be recompiled into their object code, and after that happens, then we've got to make a brand new executable. That's why, now we've been using these indirectly. They're make files underneath the surface in Dev C++, in code blocks, in Xcode, all of the big IDEs underneath the surface. When you get to the bottom level, you have these dependencies that are mapped out by your IDE. And they have to keep up with, well, when I do a build, when they touch the build button, which files have to be redone? Sometimes I've told you, I think, there's an option to rebuild all or completely rebuild your project. That goes through and changes everything from scratch, changes everything in the object code all over again. Normally, when you just click on the build, what it will do is only recompile the things that are out of date. So let's review. If all I changed was RBT.h because I had a mistake in there, then the only ones that have to be recompiled to update my project are program4.cpp because it depends on RBT.h. In other words, it includes it as an include file. RBT.cpp has to be updated because it depends on RBT.h. The MP3 doesn't have to be recompiled. This is not out of date. Nothing changed over here. So these two would have to be recompiled, new versions of the object code, and then the linker would have to link it all together again. Let's play that game again. That was so much fun. mp3.cpp, oh no, I didn't put any comments in there. I don't want to lose a letter grade in Dr. England's class just because I didn't put any comments. So I'm going into mp3.cpp and I'm going to edit and edit and edit and then save it. Now, the compiler doesn't check to see if all you did was add comments. It thinks if you edited it at all and you saved it, what it looks at is the timestamp. When was this most recently modified? It looks in the directory. If mp3 was modified more recently than the date of when this one was modified, when this file was created, that means that mp3.o is now out of date. So if I go in and add comments to mp3.cpp and I want to update my project, then what's going to have to happen is the compiler is going to have to change mp3.cpp all over again into object code, And then the linker has to tie all three of these together into a new executable. What's noticeable here is what's left out. If all I changed was mp3.cpp, the only thing that had to change in the object code level was this, mp3.o, and then the linker has to tie them all together. Since this is not anywhere over here in this big mass of dependencies of data type and RBT and all that other stuff, then none of this has to be updated. None of that has to change. And you might think, well, what's the big deal? This is actually a pretty small project. If you had a project of 20 or 30 files, you wouldn't want to have to make the machine go back and recompile everything all from the start every time you made one little change in one of your source code files. You want your project building to be more efficient than that. Don't do anything you don't have to do. It uses up system resources, and importantly to you, it takes more time. So if I only change one thing in here, I only want it to make a new object code version of MP3, not these. None of that changed. And then link it so I've got a new executable file down here. The top of the heap, look at the top of the heap up here. mp3.h. Let's say I made some little editing changes here. It wasn't quite right. What are the ripple effects of that? Well, this one has like a maximum snowball effect. Data type.h included mp3.h so that it could make the, what was it? The mp3 was the value type, I believe, not the key type, but the value type for the red-black tree. So in effect, when I changed mp3.h, I indirectly changed the data type.h. When I changed data type.h, look at these dependencies. I indirectly changed proc4.cpp because it includes data type.h. I indirectly changed rbt.h because it includes data type.h. So both of those indirectly changed, and they have effects all the way down. Look over here. If I changed mp3.h, I in effect changed mp3.cpp. Look at this snowball effect. Doing one tiny little edit to mp3.h does cause all of these green box files, well, actually the CPP files, to have to be recompiled to new versions of the object code, and then they have to be relinked into a new version of the executable file. So this top of the heap up here, even adding one comment, means the compiler has to recompile all of the source code, all the object code, new versions, and then they all have to be linked together in an executable. So that's kind of the, strangely, that's the two extremes here. Change mp3.h, it's got to change everything in a dependency graph. Change mp3.cpp without changing the h file, all I got to do is have the compiler recompile that, and then I'm ready to build the executable project. What do we learn from all this? Well, I'll kind of summarize this over here with an arrow instead of bullet points. Any change, whoa, this marker's about to dry out. Any change to a .h or .cpp file, those are the ones in the green boxes up here. These are all the .h and .cpps, the ones that we typed in using our editor. Any change to a .h or a .cpp file requires an update, which we now know is going to be a recompile, an update to the .o file, and that could be plural, .o files, as we saw with the snowball effect of mp3.h, requires an update to the .o files that depend on it. Well, if I'm going to make that plural verb, I need to get rid of the parentheses. Otherwise, it's not grammatically correct. It could be just one, but if there are several, if I change a .h or a .cp file, then I got to update all the .os that indirectly or directly depend on that in my dependency graph, that depend on it. This is the stage where we're crossing this line with the compiler, going from the green boxes to the pink boxes. Any change to a .h or .cpp file requires an update to the .o, the object code files that depend on it. Changes up here are going to require different combinations, depending on what I changed, are going to require different combinations of object code files to be obsolete, out of date, and have to be recompiled so that they'll be up to date, and you actually get to see the effect of the changes you made to the source code, for crying out loud. The CS1, actually more of a CS2 error, isn't it? Is to change this up here, and then without going through the steps that are necessary to compile it and link it to a new executable, you just jump down and change the executable. Or maybe you're actually changing a data type.h that's in a different directory. And you save it, and you think your changes are going to take, except they don't, because you've got a different executable that did not directly depend on the one that you changed. That was not a good explanation. If you change anything in the green box, then you have to make sure that you go through the stages of making it into machine code again, then assembling the machine code with the linker into an executable file. Okay, one more bullet point over here. That word is any. Here's another bullet point. Any change, C-H-A-N-G-E, to a .o file requires a change to the executable file. Or actually an update is what I called it up here. I'll do the same. Requires an update to the executable file. I'm going to have to get a darker marker. One moment, please. There. E-X-E-C-U-T-A-B-L-E. It looks emphasized, doesn't it? To the executable file that depends on it. Now, the second bullet point, you could think of that as a ripple effect. If I change my mp3.cpp, it means this is out of date. That's the first bullet point. I've got to update the .o file that depends on it. Oh no, look at this. The executable depends on that. Depends on that object file. So since that mp3 got changed in step 1 up here, now I've got to update my program for executable. Any change to a .o file, any one of these 3 .o files, requires an update to the executable down here that depends on those. So it's a matter of kind of surgically selecting or cherry picking the ones that have to be recompiled and relinked, and leaving the ones alone that did not have any changes, because that would be overkill and waste system resources. Okay? Now, carve out a box down here. This is not part of the dependency graph. It's not part of my bullet point observations over here. These were observations. OBSVS. Just right in every which direction. Here's another observation. When working at the command line, as opposed to working in an IDE where you just click a bunch of icons and everything happens, when working at the command line, oh, be still, board. Command. When working at the command line, how many times have I said that now? Comma. As the number of files in a project gets larger and larger, the files in the project are these green boxes up here, the source code files that you need. As the number of files in a project gets larger and larger, what I'll call the G++ command also gets larger and larger. Also gets larger and larger and more complicated. We don't want to type all that in, prone to errors, and as we said, it wastes system resources to redo everything from scratch every time. Gets larger and larger and more complicated. You might even have files stretched out, source code files that are scattered out on several different directories. And in your G++ command, you've got to remember what directory they're in and specify them with the slash. And oh, it's a nightmare. You don't want to have to do that. So this observation is actually a problem. A solution to the observation use a, wait for it, makefile, M-A-K-E-F-I-L-E. It's a special utility on Unix set up just to solve this problem of how do I keep up with which ones need to be recompiled and which ones don't, which ones got changed since the last time I ran this yesterday, all that kind of stuff. That's what the makefile utility will do for you. It will keep up with all that stuff. And you'll see about makefiles in the next video. Until then, see you online.